All right, joining us for another episode of the CTO Advisor is a multi-return guest. I've had Rob Hirschfeld, CEO of RackN, on a few different times, and the theme of our conversations usually end up around platform teams. His product, RackN, enables platform teams at the edge, but I think what is a common problem is what happens when we throw developer centric problems over to, we can call it operations, we can call it platform teams, whatever you want to call it. When we throw it over the fence to those teams, what happens? Rob, welcome back to the program.
Keith, it's amazing to be back. I'm really looking forward to this conversation. It's something that's been top of mind in a lot of ways for years and years. But you're right, with platform team conversations finally starting up, it's definitely coming to the fore.
Yeah, so let's give the audience some history around this. I like to give Rob free CTO advice. He's a CEO. I'm a CTO advisor. So a CTO advisor giving a CEO free advice, take it, kind of with that warranty. Like if he comes back and he says, Keith, this didn't work out. Hey, you know what? You're a CEO, I'm a CTO advisor, and the advice was free. So the a point we want to make is that this is an output of a conversation we had way back at AWS reInvent a couple of months ago. Rob was showing me his product and talking about the transformation that developers have to use to make it. And I said, man, Rob, what would be really great is if you gave me a AWS CLI into the product. That is the oversimplification of it. So that developers, if they're AWS centric, they don't have to change their preferred programming interface. They can continue to use the programming interface they love. And as a application platform team or a support team, I can change the back end as much as I want. That's the theory. Rob,
That's
let's talk a little
that's
bit about
that's
the
the
theory.
goal. Well, this is the challenge, right? And I think from my perspective, right, you get to whisper to my customers, CTOs, right, and tell them how to maximize the value of their investments, and which is really what we're always talking about. And the challenge that we've had is for the last several years, and I don't see this stopping. We have talked to the application development teams or app dev teams, right? So when we talk about developers, we're talking about the application development teams. And we've told them to be productive, be independent, go do the work you need to do, right? Operations get out of their way. You're just slowing them down, make it work. And in a lot of cases, what that's translated into is those teams using tools like Terraform to build infrastructure or AWS CLI to build infrastructure. And while that works really good for the app dev teams, when the CTO or really the CIO turns around and says, "Hey, wait a second, I need, you operations are accountable for how all this infrastructure got set up." Now that team says, "Hold on a second, I don't even know what commands you're running to set that up." Right? You're totally in the dark, let alone this idea that I'm trying to help 10 teams and they're all running it from their desktops or from their clients, right? So you can't even tell what people are doing. So you might have somebody who uses Terraform to set up an infrastructure and then runs a script on their desktop to finish that job. How do that it's hard to put that toothpaste back in the tube.
Yeah, we're going through these growing pains again when we're trying to perfect cloud-based operations.
Mm-hmm.
We can parallel the platform team to the infrastructure team of 10 years ago. If storage costs got out of control, we could look towards our storage vendors to give us an innovation like deduplication. And instead of having each application team go back and rewrite code to optimize for the various storage cost realities, from our operations team, we could just turn on dedupe and magically we're using a tenth less storage than we were before because we've reduced the duplicate records on a storage array.
Right.
That is extremely hard to do in the cloud when one person uses Terraform to describe their infrastructure. Another one uses Cloud Formations. Another one just does it by hand using the AWS CLI. And let's not get into multiple clouds. This is a single cloud
That's right.
problem. And developers, different teams choosing different methodologies. So I kind of came up with the brilliant original idea. I'm going to say no one ever thought about this before. Rob, why don't you just create a CLI proxy? Let's just for better lack of a better word, a proxy that would take those developers who want to describe their edge infrastructure or their infrastructure they're rebuilding over and over again. They want to describe it in CLI. Why don't we just make the translation for them? This is a typical thing they'll get thrown over to the platform group.
And the thing that you described, I want to explain what we built, because I think that'll help people sort of figure out how all these pieces go. But the way I heard that use case is, I want to take an existing API or AWS CLI call I'm using in a code or in script or on my desktop, and without having to change that call, I want to be able to proxy it or control it through another platform, or through Digital Rebar and through the Digital Rebar platform. And the key thing, one of the key takeaways here to me, was that it needed to not change the API from a user perspective. So if I've written a bash script and I've embedded AWS CLI in that script on my machine, or it's in a task in GitHub, or a GitHub action, or a GitLab task, right? I want to be able to substitute that command without having to worry about the script failing. So it
And
has to be able to have, fidelity. And this is a specific case, but I think this is a universal example.
and this is why we're having you on. This is why this is not a sponsored podcast, because this is a universal problem. I hear
Yeah.
this over and over and over again. Started at the beginning of my career when I went to the CIO of the Chicago Tribune. I said, "We're running out of storage array space." And the CIO told me, this is 25 years ago. He said, "Keith, storage array space, hard disks are cheaper than file cabinets. Buy more storage."
Right.
And back then, I didn't have the experience and language to explain why that's not the solution. It will help mitigate some of the problem. Yes, sometimes the answer is to buy more storage, but other times the answer is to change the overall process. And the problem with changing the overall process is changing user habits, whether those users are developers or those users are end users. Changing end user habits are extremely difficult. So when we can do it on the back end, it can be helpful. However, that was kind of our pie in the sky conversation
Yeah,
back at reInvent. You went back and you built the thing.
I
What
did.
happened?
So this is what's exciting. So we built a script. It's a bash script that literally takes, it's called aws.sh, very clever naming, but it literally just passes whatever the parameters are into that script. So instead of AWS EC2 discover instances, I can type, aws.sh discover instance, EC2 discover instances. And what it does is it creates a job in Digital Rebar, what we call a work order. That work order runs. We have a DRP CLI broker that just runs the AWS CLI. So it's an AWS CLI broker. We pass that in as a task to run that command on the AWS CLI running in a Digital Rebar instance. And then from there, it runs the command using the credentials in Digital Rebar rather than the user's AWS credentials. So there's a proxy benefit here. And takes those results, packages it up as a return parameter, and sends it back to the user. So from the user's perspective, that aws.sh is calling the AWS CLI, but it's doing it inside of Digital Rebar. And one of the nice things is, because it creates a work order for that, it creates a job for that, it creates a task, it's audited. you could actually start adding different parameters and checks. You could say, you know what, you're not allowed to do anything but the EC2 CLI here, or you're not allowed to run these extra commands. Or if you run certain commands, I want to set a log or an alert or generate additional events. So all those things become possible around what would ultimately just be an exact syntax substitute for the AWS CLI.
So people may be asking, like, okay, I don't grok the value of this.
Ah,
Let me kind of tell you why I asked for it. I'm not a user of digital rebar. I'm
mhm.
abstracting away why I want this. Why
Okay.
I want this, because I think from a managed service provider lens. If I'm a managed service provider and I'm servicing multiple customers, AWS environments, and I get to the point where I have leverage, I have some scale, and I'm getting some cost redundancies. I can now do one of two things. I can proxy all of those requests to my same AWS account and get the advantages of the reduced pricing without changing the interface for my individual customers. Each one has their context within in this platform, in this case digital rebar. Each one has their context, and then I can continue that abstraction into my managed service provider offering, or I can do something a little bit different. I can make an API compatible solution on premises. And now, instead of servicing the request via AWS resources, I can, if I have some Gen 7, Gen 8 hardware that's going to do the job, and this is all, basically free to me equipment, why not? And the from a developer experience, it's a one-to-one experience. Is that thinking valid?
There's definitely each cloud and every system has unique syntaxes. So it's very hard to make a universal AWS to something else translator. But but what this lets you do is you can actually start looking at what the calls people are actually making are, and then saying, oh, wait a second, they need these actions. Let me provide those actions. So there's an audit capability, and there is an opportunity to rewrite the task and redirect the task. But you have to have an API abstraction point to capture that. So what you're describing to me is a very real use case of I'm running these AWS CLI, and we're using this as a proxy. It's nice and concrete, but I'm running a action inside of a broader workflow. I want to be able to audit it, check it, redirect it if I need to, conform its security. One of the things that I get excited about is I could actually do a dev test prod type of work where the script we're using could actually be behind the scenes redirected to dev instances or prod instances, right? And you can actually have the same script now used in different cases, in multiple cases, and the infrastructure's code repeatability of your infrastructure starts going way, way up. All of these are important interaction points that are not easy to replicate from just the AWS CLI, right?
Yeah, and
Or any CLI, right?
and
It
these are
provides.
great insights. So let's,
Yeah,
extract away even from the digital rebar use case. I love
please.
this listening mode. We look at the 238 services that are in AWS. The reality is what the average organization might use 10, if not that. And of those 10, when you drill down and say, okay, I want to recreate some of these services or a subset of it, well, let's look at EC2. Of EC2, am I using the different? I don't know if it's a with the sizes with a combination of size and type. If there's more than I think there's more than 100 different size and type combinations. Well
Actually,
over
I think they crossed over to 1,000 just of instance types,
so
not even
just
flavors, right?
of instance types. Do I need to recreate every form of that instance type? Can I just proxy that basically we use 20 different EC2 types, and I can recreate those EC2 types on prem via my on-prem hypervisor of
Mm,
choice. It doesn't really matter. I can look to see, okay, developers in their development environments almost always go to these three different types. I can do that on-prem and not recreate a build. When they push it to
sure.
production, they use these 8 different types. We're going to continue to push those to production on AWS, but these other ones we're going to service on-prem. That is kind of the goal. But as me and you discussed last week, there are unique problems because you
Yeah.
get into, even in that limited set, you get into edge cases.
You do, and it one of the things that I think is interesting as a platform team or an operations team is coming in, you know, where you can, it's where and how you can support people as they're coming into these systems is actually a really important component to consider. So there's edge cases in how things get mapped between different infrastructures, right? You can't just take an AWS call and automatically map it into an on-premises call, a bare metal machine, or a VMware machine, VM. Those mappings do require a certain amount of understanding in how they work. Um, but one of the things that I find is just how do you answer the phone when somebody says they have a problem? And
Mm.
can they replicate the challenge, right? One of the things that's interesting about edge cases is that a lot of times an edge case ends up being something where you need real expertise or support to help resolve what that problem is. And so part of the value in this is you actually want to be able to get your experts on the line, have them duplicate exactly what happened, see the logging, figure out what went into that circumstance, and then ideally replicate it. And even more ideally, provide guardrails like you've been describing for the next pass on this. Because right, it'd be really easy to write a series of commands that can't execute because somebody doesn't have the right permissions. They're not in the right VPC. They don't have right the AMIs that they're using for the machines don't exist in the regions that they're trying to execute them on. Right? There's huge numbers of failure possibilities and how all this stuff gets fit together. Um,
And I think if you're listening to this and you're thinking through, wow, I could proxy between cloud providers. One of the terms we use in our
yeah,
conversation is supercloud. This is the beginnings of creating a supercloud. Developers all develop in AWS, CLI, or Terraform. Pick your preferred language to describe your infrastructure's code environment. You settle on one form, and then that form can be reapplied across multiple cloud providers on the platform group side. You can now proxy and say, oh, I can intercept a request that was going for AWS, and now I can send that request to Azure. That was how I was thinking from a architecture and drawing this out perspective. But we got into some of the details about that. Rob,
yeah.
talk to me. What happens when I request an AWS machine from Azure and we proxy that request?
It's interesting because at some level, machines are machines are machines,
Mm-hmm.
which is thankful. I'm thankful that when you're running a Linux machine, of a certain flavor and OS distribution, um, that OS distribution usually translates pretty well cloud to cloud, on premises, off premises, bare metal edge, wherever you are. There's certain components that you can take for granted once you get into a certain OS. Unfortunately, we're still in a very heterogeneous world where if you're using Amazon's Linux, it's different than Oracle Linux, than CentOS Linux, than Ubuntu Linux, right? You can't apt-get install, can't even apt-get installed across all the Debian distros anymore. So we do have some real differences. And this is the challenge. I actually like to describe this as a fruitcake instead of a layer cake.
Mm.
People want nice clean layers, like, oh, the storage layer is different, is the same, and the OS layer is the same, and all that. But it doesn't actually work like that. Like how a disk gets set up or a network gets set up actually has to be accounted for throughout the layers above that. You actually have to account for differences between the systems. But to your point, if somebody says, give me a Alma Linux machine of a certain generation, then I can get that from pretty much anywhere, put an SSH key on it, and give it back to you. And you can say, I want this much RAM and this much storage, and you can abstract that successfully across pretty much every platform that we encounter, which is every environment. The challenge becomes, and now we're straight back to our proxy case, the way you ask for that and the syntax you use to build that generic unit is highly variable across the clouds, even
Yeah,
within the
something as
clouds.
simple as machine ID. If you
Yeah.
inventory off of machine ID, if you create some type of SOC uh, uh, pipeline based off of the machine IDs. You've kind of figured out the identifiers within the AWS machine IDs, and you build some process on that. Well, an Azure machine ID is going to look very different than uh, a AWS machine ID, which looks different than and then the GCP machine ID.
and
The
and
machine ID.
even how you figure out which machine ID you have is variant across the
I was just
cloud.
about to say because the machine ID field may not even be the same field across cloud providers. So that metadata problem becomes a operational issue because these unique identifiers, just operationally, we us op guys, we optimize based on the things we can optimize on, and machine ID ironically becomes one of those things that become critical unattendedly.
Yes.
So Rob, we talk about this stuff all the time. I was just talking to a young CTO, and he was saying that he just doesn't have relationships. And I'm thinking, man, Rob used to run this weekly thing called uh, Cloud 2030. We're
Yep.
surprisingly getting a little close to that. We might need to push out to Cloud 2040. Uh, if people want to engage with, they want to like bounce
Yeah.
ideas off of you. How do they find you? How do they
We
engage with you?
we we are still having a weekly DevOps lunch and learn roundtable, and it really is a roundtable. People bring topics and we discuss it. And I love the format because we spend 15 minutes completely off agenda, and then usually we'll try and jump back to some planned topic of the day, which is some Kubernetes or platform engineering or API design, classic DevOps stuff. People can find out more about it at the 2030.cloud. So it's I couldn't get the cloud 2030, but the 2030.cloud. We post the agenda for that. We actually also do a broader strategy breakfast where we talk about much more esoteric topics like metadata context for artificial intelligence data gathering, and the future of internet regulations. Both are important. But they're great places to engage and ask questions like this. Very pragmatic, and generally what I describe as 201 level type stuff. So not how do I use Terraform, but oh my god, I'm using Terraform and I've gotten to a point where it's really hard and difficult to scale because I'm storing the files in different places, or I've got 100 copies of the same plan and I don't know what to do. That those are, which are very real, right? Everything we're talking about is an acknowledgement that cloud complexity is real, um, and you have to be deliberate in how you scale it. But that's the Cloud 2030 conversations. Go to that. A lot of fun, very casual.
Yeah, and I don't attend as many as I want, but every time I attend one, I learn something new. It's a eclectic folk from the super technical like Rob to the less technical like me, and it's a really great conversation. If you want to learn more about the CTO Advisor, you can follow us on the web, thectoadvisor.com. You can at me on Twitter at CTO Advisor. I'm just looking at Rob's feed out his window, and it looks like he's getting a package. So Rob will let you go. Talk to you next episode of the CTO Advisor.
Keith, thank you. It's been a pleasure.